I want to start off today by going over yesterday's problem number 12 from the assessments. There were several questions about it, and for those of you who didn't even ask the question, I just wanted to make sure that you understood what happened here. So the original question number 12 was the quantity x minus 9 squared is equal to 25. To give you the example and explain this better, I wanted to show you about the x squared equaling 25 and use it as a comparison. So with x squared equaling 25, you know that what we would normally do is take the square root of each, and then you would end up with x is equal to a plus or minus 5. Positive 5, negative 5, two answers. Because it's a quadratic, it will have two roots. So going back over and looking at the problem number 12, it's similar because if you see, both of those things are squared. So I have the 25 squared, and I have the quantity x minus 9 also squared. So I'm going to do the same thing that we did for the problem on the right. We're going to take the square root of both sides. So the square root of 25 is plus or minus 5, just like we said before. And then the square root of this is x minus 9. Let x minus 9 just pretend that that's an x squared, and we're going to take that and just write x minus 9. So now because it's a quadratic, it's going to have two answers. So now I'm going to set it up so that x minus 9 equals a positive 5 and an x minus 9 equals a negative 5. Think back to when we did absolute values and we knew that the absolute value meant that we had two answers. Well, we have two answers here too. So once you solve those initial equations, you should get that x is equal to 4 and 14. I hope that makes more sense so that you understand how to do problems that have quantities. So now to get into today's lesson, we're going to be doing section 8.6, solving quadratic equations by factoring. Yesterday we did it by square roots. Today we're doing it by factoring. In order to get started, I want to do a quick warm-up, finding products and finding factors. So question number 1, the quantity x plus 2 times the quantity x plus 7. What is that product? Question number 2, the quantity x plus 2 squared. What would that be as a polynomial? Don't forget what that squared means on the outside. Question number 3 is factoring. Take the trinomial x squared plus 12x plus 35 and find the two binomial factors. Question number 4, find the factors of 2x squared plus 16x plus 32. Make sure you're very careful because if you look at that expression, you'll see that there's a common factor of 2 in each. One of the problems from the slide before talked about x squared plus 12x plus 35, and it asked you to factor. Well, all we're going to do now is we are going to make it into an equation. So what we're looking for here is the x values for when y is equal to 0. So we're going to factor it first, which is what you should have gotten on the practice from before, and you'll get x plus 5 times the quantity x plus 7 equals 0. Now, take a look at this particular equation over on this side. If I have two factors that multiplied together equals 0, one, the other, or both of them have to equal 0 to get that product. This is called the zero property. That's what our textbook calls it. So, as an example, 0 times 7 would equal 0, or 5 times 0 would equal 0. So either A has to be 0 or B has to be 0. And that's exactly what's happening when we factor. Once we factor, we should find that x plus 5 has to equal 0 or x plus 7 has to equal 0. One of those two factors has to equal 0 so that when I multiply, I will get 0 for my answer. If you solve those two equations, you'll find that x is either a -5 or a -7. Substituting back in, if you put in a -5 plus 5, that's 0, and 0 times no matter what this quantity is will give you 0 for an answer. Let's try another. X squared plus 4x equals 0. Yes, it's in standard form, and looking at it, it just doesn't have a c. What I do find is that it does have a common factor, and the common factor is x. So I take out the greatest common factor of x, and I'm left with x plus 4 in the parentheses. Again, I'm going to do the same thing. I'm going to separate it because either the first factor, the x, has to equal 0, or the x plus 4 has to equal 0. So my two solutions are x equals 0 and a -4. Look at this one. Standard form, yes. No greatest common factor. We're going to factor it first. Once we do that, we're going to set each factor equal to 0 and then solve those two little equations. So x equals 3 and 4. Start with this one. Is this in standard form? Nope. And since it's not in standard form, we need to put it in standard form. So I move it so that I have all of my terms, my ax squared plus my bx plus my c, all on the same side, and I set the whole thing equal to 0. I did that by subtracting 21 from both sides. The next thing I'm going to do is factor. And when I factor, I get x plus 7 times the quantity x minus 3, still equal to 0. I set each factor equal to 0, and I get x is equal to a -7 and a +3. Notice, those two numbers are not in parentheses. They're the x coordinates when y is equal to 0. They're the roots. They're the zeros. They're the x-intercepts. They're where the parabola will cross the x-axis on the graph. And there are two places where it crosses. And the places they cross would be -7, 0 and 3, 0. Your turn. First, put this into standard form. You'll notice that when I put it into standard form, I moved the -x squared, -2x squared, over to the right-hand side so that all of my terms would be positive and set the whole thing equal to 0. What do you notice in that particular quadratic? There was a common factor of 2. And that left x squared plus 10x plus 25 inside the parentheses. Factor that, just the parentheses. You should have gotten 2 on the outside still, and then x plus 5 times the quantity x plus 5. My final answer is that x equals a -5. Notice, x plus 5 times the quantity x plus 5 is a perfect square. So you only write x equals a -5 once. What do you think that means? Once you're finished answering that question, go and try the really cool drop and drag activity to practice solving quadratics by factoring.